1.4 quadratic equations and applications. Really, when you get that down to it, this section is all about solving and different ways to solve. Okay, so the first section says, example 1, solve by factoring. One thing I notice is that I have two x's. I have x squared and x squared and x squared and x. So I should be able to factor all three at least, hopefully. First thing you should always do when you're solving by factoring is set it equal to 0. So I'm going to subtract 3 there. So I'm going to have, I don't want to actually do that parentheses, 2x squared plus 9x plus 4 is equal to 0. Now you should check to see if they have anything in common. Do 2, 9, and 4 have anything in common? They sure don't. So now I'm going to break that up. So 2x squared can be broken up with 2x times x. Now I have to figure out the pattern for 4. Now my two options are either 2 and 2, 4 and 1. Here's the thing. Because of this 2 here, and because neither of these three terms have anything in common, I don't even have to test these two. Because if I plug that 2 there, that 2x and a 2 would have something in common, and they shouldn't. If they don't have anything in common here, they should not have anything in common in our smaller ones. So I'm not going to test that. Same thing here. Now I have a 4. Well, 2x and a 4 would have a common factor. So I'm going to put my 4 here and my 1 here. So now 2x squared times x is 2x squared. Then I would have 2x times 4 would give me 8. 1x times 1, or 1 times x is 1x. Together that equals 9. So both of these are positive because I have to multiply to get a positive 4. Equals 0. So now when I'm solving, I can just set these both equal to 0, like we have done in the past. Subtract the 1, divide by 2. X is equal to negative 1/2. Here, subtract the 1 and negative 4. Bing, bada, boom. For the second one, first I want to look to see if they have anything in common. They do. They have a 3 and an x in common. When I take out that 3x, I'm left with 2x. Remember, when you're factoring something out like this, you're undoing the math, that multiplication. So this is like dividing by 3x gave me a 2x. Dividing by a 3x here would give me just a 1. So now because I do not have any x's or x squared left, now I can finish solving just like how we did up here. I want you to pause the video, finish solving this, and solve this one by factoring. Here you got 0, because I'm going to divide by 3, get 0. Add 1, divide by 2, get 1/2. Subtract the 6, then I factor, and I get 5/2 and negative 1. Now for this example 2, when I'm looking at this example 2, the difference between these up here and here, I just have one x variable. So I don't have to factor. I can just get x by itself by undoing the math. So the opposite of multiplying here would be by dividing. So I'm going to divide that 4. Opposite of squaring something is a square root. This is where you have to be careful. When you take the square root, when you're solving for something and you take the square root, you should have 2 answers. A hint for that is the fact that this 2 is right here. Your degree is kind of a hint of how many different answers you may have. So that right there would be my final answer. Same thing here. Backwards of PEMDAS means I have to get rid of this squared first. So the opposite of squaring something is the square root. Now, right here is where that positive negative comes from. I still have to move this over. I still have to add 3. These are not like terms. So my final answer would be a positive 3 plus or minus the square root of 7. Let's just pause the video and do C and D by yourself. So if you got your answer as plus or minus square root of 12, you are halfway there. So you have to remember how to simplify radicals. You should always simplify all the way down when you can. So you can either do this by the factor tree. So the two numbers that multiply to get 6 or 12 are 6 and 2. 6 would be 3 and 2. You're breaking it down to prime factorization. Here's a pair of 2's. So 1, 2 comes outside of the root. This 3 had no pair, so it stays inside. Or you can solve it by perfect squares. So you know that 4 is a perfect square. So you know, oh, I can rewrite this as the square root of 4 times the square root of 3. Well, the square root of 4 is 2. Square root of 3 stays right in. The second one, I have to first add over the 2. Then we take the square root of 12. Now we already did that hard work up here. I'm not going to rewrite that word because it's already right there. I still have to move over this plus 1. So opposite of plus is a subtract. Again, these are not like terms because of that radical. So these are your 2 final answers. And now we're getting into completing the square. Now this might be new to some of you, and it can be confusing. So first up when I'm completing the square is I'm going to rewrite the 2x squared and the 8x with a space here, and then a plus 3 with a space here is equal to 0, because that's where I'm trying to complete the square. And actually, the first thing you want to do is see if this can be factored. So right away, I can take out a 2 of both of those. So now I'm just focusing on this. So I can take out a 2 of both of those, 2 on the outside, leaving me with an x squared plus 4x, leaving my space, plus 3. So I really didn't change anything besides factoring out that 2. When you're completing the square, this has to be equal to 1 right here. Then you look at this term, your b value. You take your b value, so this is my b value, divide by 2, and then you square it. This number, so in this case 4 divided by 2 is 2, squared is 4, is the number that goes right here. So in this case this would be plus 4. But you have to balance this equation out to these two lines. So I'm not actually just adding 4. This, actually, because this is in parentheses, is me adding 8. So if I'm adding 8 right here, I have to make sure I'm subtracting 8 over here. So now what I have is I'm going to combine these two terms, and now I'm going to factor this. So I have 2. This becomes, again, if you're going to factor this, two numbers that multiply to get 4, add together to get 4, is x plus 2 squared, because that's what we just did. We want to rewrite this so it's nice and even like that. So it's this x plus 2 times x plus 2. This becomes minus 5 is equal to 0. And now I solve this. So I want you to pause the video and finish solving that equation. And you should have gotten negative 2 plus or minus the square root of 5 halves. Now, technically, this is not in radical form. We'll get into that later. So for the second one, same thing. I'm going to look to see if I can pull this out. Now, first thing you notice is that these two terms do not have anything in common. So there's actually a little bit different thing I'm going to be doing here. Because of that, I'm going to have my 3x squared minus 4x, and then my number, and then minus 5, and then my number is equal to 0. In this case, I'm going to divide each of my terms here, divide by 3. So essentially, I'm dividing this by 3. Whatever I do to one term, I don't know what this is yet, so I don't have to touch that yet. I'm going to divide by 3, each one. So now what I actually have is this x squared, because 3 divided by 3 is 1, minus 4/3 x. We don't know what we're going to put there yet, minus 5/3. This is still going to be equal to 0, because 0 divided by 3 is still 0. Same thing we did up here. Now, if you want to show this in the calculator, you can just go in parentheses, negative 4/3 divide by 2. So this number right here, close that parenthesis, squared. Now it's a fraction, so I'm going to put that into a fraction, 4/9. So I'm going to add 4/9 right here, plus 4/9. Now because there's no number out in front, or if I'm going to add 4/9 here, I need to subtract 4/9 here. You have to even that out. Now a couple of things, when I rewrite this, I have to factor this. Now this is the part where people might be like, oh my gosh, how would I going to factor with that fraction? This right here is your friend. I can also do this, negative 4/3 divided by 2. I'm going to change that to a fraction. That number is what goes in this parenthesis right here. So when I factor this, I have my x, because that's negative, minus 2/3 squared. Now, I'm not the best at doing mental math right here, so I'm going to go negative 5/3 minus negative 4/9. Change that to a fraction. So I have minus 11/9 is equal to 0. Now, this is going to be very beneficial if I were looking for the vertex. Right now, I want you to finish solving that problem. You should have gotten 2/3 plus or minus the square root of 11 over 3. Where did this 3 come from? Well, I took the square root. Remember, square roots, you can have square root of 11 over square root of 9. You do have to know your perfect squares. It'll make your life easier. Square root of 9 is 3. That's where that 3 came from right there. I want you to pause the video and try to do C and D by yourself. Pause the video to look at my work if you need to, but your two answers should have been 1 plus or minus the square root of 1/2 and 5/3 plus or minus the square root of 43 over 3. Last but not least, quadratic formula. So you have to know your quadratic formula. If you don't know your quadratic formula, this is it. Opposite b plus or minus. Notice how I said opposite b. Opposite b plus or minus the square root of b squared minus 4ac all over 2a. You have to first know what a, b, and c are. You have to set this equal to 0 first. Should we do this one? Sure, because it looks like it has a number for a. So I have a is equal to 3. That number's on in front of the x squared. B is equal to 2. And c is equal to negative 10. So if I plug this in, it's opposite b plus or minus the square root. Make sure to always put this in parentheses, minus 4ac all over 2a. Now the biggest thing here, because I want the most precise answer, just put this portion into your calculator. So this becomes negative 2 plus or minus the square root of 124 over 6. This is where you have to simplify this root. I'm going to do my factor tree, and I already divided it by 4. That's what I checked first, a perfect square, and 31. So I know that this is going to be able to simplify. This right here, I have a pair of 2's. I'm also going to rewrite this in 2 separate fractions. Because this is divided by 2, plus or minus, I just take this 2 out of this root, square root of 31 over 6, because both of them are divisible by 6. I can simplify this fraction, so that fraction would be at negative 1/3, and I can also simplify this fraction. I do not touch that root. That root is untouchable. You don't need to have that 1 right there, but you sure can if you want to. And this right here would be my final answer. Pause the video and try to do A by yourself. First step is to subtract the 9 over. You can pause the video if you want to look at my work. Final answer should look something like this. And by 5, I mean 2. Sorry about that. Have a grand, have a wonderful evening.